Okay, so here is another ACT released question. I actually don't know whether this is copyright ACT, but it's copyright somebody that's not me. So it is asking, what is the slope of PQ? Notice that we've got, let's go ahead and use some colors here. Notice that we've got P right here, okay, and Q right here. And if I were y'all, and I was working on an ACT test, I would definitely make sure that I wrote on the test and marked it up, because it's really it's okay, and it's kind of like important that you problem solve, like getting your body involved, even if it's just getting your pencil involved with your hand. Okay, so it's asking what the slope of this line is, and it's a line that is defined by these 2 points here. Now, slope, we say that slope is equal to rise over run. And the reason that we say that is that we want to talk about like what rise is. Okay, you know, to rise is to move vertically, right? Up and down. That is rising. Well, only going up is rising, really. But it doesn't matter. It really is, it's referring to this action of moving on a vertical direction, moving in a vertical direction, okay? So, which of these axes moves in the vertical direction? Okay, rise, okay, refers to the vertical direction, which is your Y, okay? Rise is vertical, which is Y. Now run. Usually you don't run up and down, right? Usually you don't run straight up and straight down. As a matter of fact, here we have a little advantage as far as this goes here in New Orleans, because we don't have any hills here. So we always, when we run horizontally, okay? Horizontally. That's how we run. We've got this flat ground here in New Orleans, and we're running on this flat ground if we even run at all, which I hope you do, because it's good for you, okay? So we're going that way or that way. So your run, which is horizontal, is going to be part of your x-axis, okay? So that's horizontal, and that is your x, okay? So when it says that slope equals rise over run, what it's saying is that your slope is going to be your, I love this, we use this in calculus. Why don't we use this everywhere? Because it makes sense. Your change in y over your change in x. Delta y over delta x. Delta means change in. You don't need to worry about that. What you need to worry about is, you need to worry about this part right here. Your slope is your y, your difference in your y over your difference in your x. So, if I'm looking at this, I don't even need to do any math here. Okay? Let me kind of show you here. This is P right here, right? This is and this is Q right here, right? So what you need to do is you need to count how many squares are there when you're going up from where P was to where Q was. In other words, this kind of shows me where the vertical part of P is, and this kind of shows me where the vertical part of Q is. And right here, okay, this is the vertical thing I'm saying. Looks like I have 2. Looks like I could put 2 up top here, right? 2, because it's going up 2. Okay? And then, then here's where Q ends, right? So I got to go over, and it looks like there's 1, 2, 3 spaces between P and Q. Okay? It looks like my run is going to be, I should have made my rise, I've got to make my rise lightning yellow instead of red. There's my rise, lightning yellow, and it goes up 2. And here's my run, okay? It's green, and it's going 1, 2, 3, okay? So I end up with, I got to make this lightning yellow, okay? I end up with 2 over 3. And it really is that simple. I swear to God it's that simple, okay? So in the case of this, what is the slope of PQ on the graph below? I counted, and I found out that the answer was 2/3. That is pretty awesome, okay? Don't forget that. You can count, literally count physically on the ACT and get an answer right.